let's go back to some data I presented earlier about the prevalence of depression and artery blockage in a large cohort of elderly men and women in Rotterdam. We can use these data to calculate some odds ratios. But before we do the odds ratios, I'm first going to calculate for you the risk ratios. This study had divided people into 3 levels of coronary calcification: low, medium, and high. It also looked at the prevalence of depressive disorders within each of those groups. So you can see that as you went up in the coronary calcification levels, that you're going up slightly in the prevalence of depressive disorders. To calculate the risk ratios here, we have to pick one of the groups to be the reference group. So I'm going to pick the lowest coronary calcification group. That also has the lowest prevalence of depressive disorders, so it sort of makes sense to make that the reference group. To calculate the risk ratio for the median group compared to the low group, then I'm going to divide the 2.3% by the 0.9%. I get a risk ratio of 2.56. To calculate a risk ratio for the high group compared to the reference group, I'm going to divide the 3 by the 0.9. I get a risk ratio of 3.33. How do I interpret these? That 2.56, you would interpret that those with moderate blockage in the medium group of coronary calcification have 156% increased prevalence of depressive disorder compared with those with the least blockage. The 3.33, you would interpret that as those with the most severe blockage have a 233% increase in the prevalence of depressive disorder compared with those with the least blockage. Okay, so those are the risk ratios. And you might think it would be just natural to report the risk ratios here. I mean, this is a cross-sectional study. It's not a case control study. The risk ratios are valid. Why would you report anything else? However, if you look at the paper from the study, you'll notice that when it came to reporting measures of relative risk, the authors actually reported odds ratios, not risk ratios. So what's going on here is that the authors wanted to adjust for confounders. So they used logistic regression, and as I said, logistic regression gives you odds ratios. And if you read very carefully in a little footnote here, you'll notice it says odds ratios were calculated with logistic regression, and they even tell you all the confounders they adjusted for. This was obviously an observational study. There were lots of potential confounders they wanted to adjust for. So they adjusted for things like age, sex, cholesterol, cognitive score, lots of things. So that's why they're reporting odds ratios, because they did this multivariate adjustment with logistic regression. Logistic regression gives you odds ratios. I'm now going to walk you through how to calculate odds ratios using, of course, the unadjusted percentages. We're going to use the unadjusted numbers, so we're going to get slightly different odds ratios than the authors got when they used this multivariate adjustment, because, of course, when things are adjusted, they're going to shift slightly. But we're going to get, actually, you'll see we get pretty similar numbers. The first step, before we can calculate an odds ratio, we have to calculate an odds for each group. So for the low coronary calcification group, the risk, the prevalence of depressive symptoms was 0.9%. Therefore, the odds is the risk, the percentage, divided by the risk of having depressive symptoms divided by the risk of not having depressive symptoms. So the risk of having depressive symptoms was 0.9%. The risk of not having it, therefore, was 1 minus 0.9%, or 99.1%. So that's the odds of depressive symptoms for that group. For the medium coronary calcification group, we would divide the risk, 2.3%, by 1 minus that, 97.7%. That's the odds for the medium group. The odds for the high coronary calcification, the severe blockage group, is 3 divided by 1 minus 3%, which is 97%. So those are how to calculate the odds. The odds ratio is then calculated by making a ratio of odds. And notice there's lots of fractions running around here, so it's got to keep track of everything. We're now going to make the odds ratio by taking the odds in each group and dividing it by the odds in the reference group. I'm again going to make the reference group that 0 to 100, that low coronary calcification group. So to calculate the odds of the odds ratio for depressive symptoms in the medium group compared with the reference group, I would take the odds in that group, which was 2.3%, divided by 97.7%. That's the odds for the medium group. I'm going to divide it by the odds for the reference group, which was 0.9%, divided by 99.1%. When I calculate that out, I get a value of 2.59. Again, slightly different than we got for that the authors got for the adjusted odds ratios, but pretty close. For the high group, the odds ratio will be the odds in the high coronary calcification group, that's 3% divided by 97%, divided by the odds in the reference group, which again is 0.9% divided by 99.1%. You can see you're dividing a fraction by a fraction, so a lot of fractions going on here. So when you actually calculate that out, you get a value of 3.41. So the odds ratio of 2.59 would be interpreted as a 159% increase in the odds, not the risk, the odds of depressive disorder. For the 3.41, that's interpreted as a 241% increase in the odds of depressive disorder. And notice that it's an increase in odds and not an increase in risk. And that distinction is actually not important if you have rare outcomes. But as we're going to see in the next module, that distinction of odds here is very important when you have common outcomes, because the odds ratio is going to be very different than the risk ratio in those cases. So again, notice we have in this case, we have a rare outcome. Depressive disorder was very rare here. So the odds ratio and the risk ratio, the unadjusted odds ratio and the unadjusted risk ratio are very similar. We calculated the unadjusted risk ratio to be 2.56 earlier. For the odds ratio, it was 2.59. They're almost the same. For the high group, the more severe coronary blockage, it was 3.33 was the risk ratio, 3.41 was the odds ratio. Notice the odds ratio is always bigger, but the difference here is so small that when you have a rare event, it turns out that you can interpret the odds ratio as you would a risk ratio. And that's usually the case when we're talking about a case control study, because we usually do case control studies because of the outcome we're interested in is rare. However, when the outcome is common, as is often the case in cross-sectional studies or cohort studies, the odds ratio and the risk ratio are not similar. They can be extremely different. And if you interpret the odds ratios wrong, that can be very misleading, as we're going to see in the next module. I just want to reiterate, you might be wondering, why the heck do we ever calculate this confusing odds ratio? So again, there's two reasons. You need the odds ratio because it's the only valid measure of relative risk for a case control study, and because sometimes authors want to run logistic regression, and logistic regression gives you out odds ratios, and so that's what people end up reporting. So that's the two main reasons you're going to end up seeing odds ratios. There's nothing wrong with an odds ratio. It's simply that you have to be very careful in your interpretation so that you don't end up misleading your readers. Finally, I want to challenge you to practice calculating an odds ratio on the Vioxx data. So take the data you see on the screen here. In a moment, I'm going to ask you to pause the video and try calculating the odds ratio on your own, and then restart the video, and I'll walk you through the calculation of the odds ratio here. All right, so hopefully you had no trouble calculating the odds ratio here. So to calculate the odds ratio, we're going to calculate the odds for the Vioxx group. That's going to be the numerator. That's 0.42%. And that's the chance of getting a heart attack. The chance of not getting a heart attack is therefore 1 minus that, which is 99.58%. That's the numerator. In the denominator, the odds for the naproxen group is 0.1% divided by 99.9%. When you calculate that all out, you get an odds ratio of 4.21. Now remember that our rate ratio and our risk ratio here were 4.2. And so the odds ratio is almost identical here to the risk ratio. Well, why is that the case? Because the heart attacks here was such a rare event, right? We're talking about a very rare event. When you have rare events, again, odds ratios and risk ratios are similar, and you can see that here.